Thanks for choosing this session. Good on the volume? All right. You have to suffer through about 6 to 7 minutes of business stuff, and then there's a link up here for all the code that we're going to present today as well, so it'll be a pretty technical session. So Better Cloud does multi-SaaS management. Anyone know what that is? Yeah, I didn't know what that means either, so just step back a couple years. SaaS wasn't too crazy, but now there's so many awesome SaaS applications out there that it's hard for IT admins to be able to deal with all of these different SaaS applications, to go in and create users in all of these and keep things up to date and keep tabs on everything is quite a challenge if you're an IT admin. And so that's who Better Cloud serves. So IT admins install our product, and then they will select the different SaaS applications that they have. They'll give us access or authorization to the API so that we can ingest from Google, Salesforce, Slack, etc. We can start to ingest all that data and bring it into our system so we can provide this mission control for IT admins. So now through one browser or one tab in their browser, they're able to see all this data centrally across the users, groups, files, third-party apps that they've installed, and then they can take action on it as well. They can do it in bulk or individually, or they can just set it and forget it and automate those actions. And what we talk about here as well, when you have all these different SaaS applications, and you're that IT admin, if you put yourself in their shoes, and you're responsible for how all of these different systems are operating, whether or not they're in sync or not. We have to provide them intelligence because it's really hard for them to go into every single one of these applications every day to look to see if things are out of line or if there's something that's not meeting company policy. So going a little bit deeper, we're processing hundreds of millions of messages a day. Just the Google icon alone here, we have 17 different endpoints that we're ingesting if the customer picks Google as just one of their SaaS apps that they had. So we have teams that just focus on data ingestion. That's their sole purpose. There's certain patterns in there. It's its own problem domain, and that's what actually creates the stream for us. They're ingesting this data, and they're putting it into Kafka, and that's the first time that the data stream gets initialized, really, for us when we talk about stream processing for Better Cloud. The next set of teams will pick up that data from the stream, and we'll start to normalize that data and centralize it so the IT admin can see that data at one place and make heads or tails of it and not have to go into 20 different systems. So put some screenshots to some of these words. Here's an example of the users grid. We have groups grid, we have files grid, connected apps grid, etc. There's just one example. But you can see here now the IT admin can see that these users have more than one SaaS application, and then they can go into the details and see, say, all the memberships that they have for one of those. They're in this Slack group, or they're in this Google group, and this Dropbox, etc. To manage all that. And this team also can, as they're putting this stuff in a grid for search, sort, and filter, it's stored in a database, but they can get more granular in terms of the event. So they can see if someone's manager changed or someone's title changed, someone added a file or changed the permissions on a file or installed a new application. So they can add those events in that same data and put it back into the data stream for the next team, which is most of this talk is about, for the intelligence. So we can start to look at that data in the stream for things that violate company policy. Why did an intern share a file with the public? That's not supposed to do that. Or if we have say 4 super admins in the company, and now a 5th one just got created. Like who created that other super admin? We don't want any more than 4. And here's another picture to go along with these words. So here's an example where they see an alert and they want to go into the alert details, and they can see that these are the users that haven't implemented two-factor authentication yet within Slack, and that's against company policy. Everyone has to have two-factor authentication set up. So this team will then flag on these items that don't meet, if it doesn't meet that policy, if it exceeds a threshold, then it needs to flag it. And so after those items are flagged, it might decide to take action on them, either individually from that details page I showed you, or from that whole grid. They can select everything in the grid, everything on that page, everything that matches the query, or they can automate it. They can say, anytime this event happens, just automatically kick off this series of events. If someone shares something publicly with a link, email the person, email the manager what the policy is, change the permissions on the file, whatever they want to do, send a Slack message. Again, just some quick examples of, here's that users grid again, where they've selected a couple users, and then they pick up they select the action button, and then they can start to say, of these different SaaS apps, I want to take this action on this set of users. Maybe these are the users that didn't set up their two-factor authentication for Slack, so send them a Slack message, or send their managers a Slack message. And then for the automation part, this is where Flink comes in, where it's looking at these events. So when this happens, if it meets these conditions, then flag it and take these different actions in the workflow. These series of actions that can go across the different SaaS apps. But this is where, with Flink, we use Flink heavily in the alert detection, the policy enforcement, where we're going to look at this stream of data, see how that is, see whether or not it's in compliance, and flag it so that the person can, the IT admin, that poor cloud IT admin, they can either take action manually or they can automate it through a workflow. So this is the business domain, or the problem space that we're in, that the team had to solve. They needed to be able to, we need to alert quickly. We can't say that someone shared a document publicly 12 hours ago. It's got to be quick. Tremendous scale. We're doing 100 million events a day, and we're adding connectors every month with other SaaS vendors that you don't see here yet. We got to keep innovating. We can't do releases every 3 months. We have to do daily deployments. All of our teams do continuous delivery, multiple deliveries a day, microservices architecture. We're constantly trying to validate the customer's needs and get out new value to them. And we got to demonstrate the power. Once you install a connector, we want to be able to demonstrate what our platform's able to do. Start showing them alerts for Dropbox. Here's files over 25 megs, for example. Just global alerts that we start applying the second a customer installs a connector. And once they see that, all customers, good customers that they are, they want to change it, right? They want to do more than what we just provided out of the box. So we also allow them to create their own alerts, their own custom policies, so that they can flag things based on their needs. So we have to support not just global alerts, but alerts for every single customer, multiple alerts per customer, multiple policies per customer. And we could do all that, but we wanted to be cooler than just saying, hey, from this point in time, go ahead and start doing counts. We wanted to go back in time and replay events, because we have data for customers. We might have a new alert that we came up with, some new machine learning or some complex event processing. We want to add this alert, but they've been a customer for 6 months or a year, and we want to go back through all of their drive data and apply that data against this alert. We don't want to just start from this point forward. So you will refer to this throughout this presentation as bootstrapping. So that's kind of our jargon that we talk about, but it's us going back in time, going back through the alerts. And it's also a nice feature if there's a bug in the alert. It's good to go back through that alert and replay it. So you're probably wondering, hey, this is pretty cool. I would like to go really deep. And can you go a lot deeper into how you guys did this? I cannot, but Sean and David can. So I'll bring them up here.
Starting over? Oh. Really? All right. This better? All right. Sounds a little loud to me. Hey, I'm Sean Hester, Director of Engineering at Better Cloud, providing architectural support and leadership for the operational intelligence group that Hardwick was telling you about. Okay, that's about as far as I'd gotten. Before we get my teammate, David Brelloch, up here to walk you through some code, I want to just give you a little bit of a backstory about the architecture, introduce you to a couple of concepts, make sure everybody's on the same page. Before we worked on this project, David Brelloch and I actually worked on another similar project with Better Cloud. It didn't go quite as well, and I wanted to kind of give you some of the key learnings that we had from that project. Okay. So first, we're really strongly convinced at this point that event stream processing is a better architectural model for operational intelligence than ingest and query. Ingest and query is what we had done before. Maybe what a pattern that most of you are familiar with is where you basically just read in as much as you can into a single database, and then you periodically run queries on it to extract your operational intelligence. And from our experience, it pretty much sucked. It had a lot of bad downsides. Very slow and inefficient, required a lot of redundant processing on the data. Very high latency. You remember kind of some of the goals that Hardwick had up just a slide or two ago. We don't have time to wait for minutes or hours to surface the latest data. It's also very data store intensive, and not just data store intensive, but you got to get to like the exotic data stores that really run best on solid state drives, et cetera. So you're paying a high dollar to get a data store that can handle that kind of combined read-write load for that query and ingest model. And then worst of all, in my opinion, is that model focuses on state rather than on state transition. And a lot of what we care about in operational intelligence is those state transitions more so than the state itself. So you run a really high risk with ingest and query of missing key pieces of data because you've simply overwritten old state with new state, and you really cared about, oh, this person did transfer to a new department, or they got access to a new folder somewhere. Those are the things that we tend to care about most. All right. So the second is that rules engines add significantly more value than hard-coded rules. And a lot of you may look at me like, well, duh, I know that. But when we started out with our first project, we did the hard-coded rules thing, and it also sucked. So just another quick couple of reasons. They're slow to develop. They're hard and expensive to maintain. They're boring. Your engineering team will hate you very, very quickly. And additionally, they take a much longer cycle time. They don't give you the flexibility to do things that we wanted to do, like give our customers the opportunity to customize the kinds of things that they cared about. So for this first one, it was actually a pretty easy sell for us. As you may have noticed from Hardwick's slide here, this is all basically a set of separate but ultimately continuous streams from one column to the next. And so we didn't really have to work very hard. It's like, oh, okay, you're already delivering messages to us via Kafka. All right, we can work with this. It's actually pretty sweet. They teed it up very nicely for us. For the second point, the rules engine, we had more choices, a little foggier for us. So I'm old enough that I have actually a fair amount of experience with the XML stack. And I had a joke here for how Douglas Crockford has killed XML. And then I'm pretty sure I clocked during the Netflix keynote that they are actually supporting XML and using XPath for their querying. So on the one hand, it's great to see that we're not the only people doing these kinds of things. On the other hand, the XML stack is not dead, so don't write it off. But for us, we were already standardized on either Avro or JSON as our serialization format, so we went with JSON Path. Specifically, we're using the JWay JSON Path implementation. We've liked it very much so far. And I'll give you a little background on JSON Path so that what David will walk you through makes a little more sense. JSON Path executes queries against discrete JSON documents. And from our standpoint, it provides a very simple, handy way to wrap non-technical user interfaces around a query. And then as a bonus, since there are JavaScript-based versions of JSON Path, I won't show you this, but we do have a new one a new interface we've just brought on that actually lets the user validate their JSON Path query against a static JSON example event, and they can validate that their query works as expected before they even submit it to our streaming jobs. So that's actually very handy. We're very excited about that one. Okay, so for those of you who aren't familiar with how JSON Path works, it basically parses the document into a tree. And in the most basic form, you start with a $sign at the root, and then you can walk the tree structure of the document using the dot notation that everybody's probably pretty familiar with. It will do some casting, some dynamic typing of the values, so that you could test for equality of a number at a particular node in the tree or a string at a particular node of the tree. In addition to just simple dot notation, it also supports, you can see that the third example there, store book 0, indexes into the book array. And then it just it gets increasingly more complex from there. It supports a subset of the total JavaScript operators that are available. So we can test for the length of an array. And then you get really funky down the last one. You can actually do these kind of conditional queries where show me the books where the category equals fiction and the price is greater than 10, and that would return you the JavaScript, the JSON node for that second book in the book array. It also will support and or operators within those same queries. So for any one query, you can actually get fairly complex. It's pretty sweet. So we take the basic DSL of that query language, and we can provide access to it to our end users via an interface like this one, for example. We have this form that you can go in and create a custom alert looking for specific kinds of events. And this entire section of this alert trigger conditions that's highlighted in pink, you can add a set of specific queries to say that this is what I want this alert to trigger on. Okay. Once the user is done configuring what they want to alert on, they save that, and that gets submitted as a control event. So we submit that alert configuration to a control topic, and we use control events fairly liberally. Some of you may as well. For those of you who don't, I highly recommend them. In the case of getting Flink job to behave dynamically, that's a great way to tell it, hey, it's time for you to update your logic. In this case, it's, hey, here's a new thing that I want you to look for. Add this to your list, and then as new events come through the regular data stream, you can evaluate them. For most of our jobs, we actually, the functions are some variation of co-flat map. So they literally have a designated function for taking in the control events. At this point, we've got close to 24, I think is what I heard from one of our engineers earlier. So yeah, anything from, hey, here's a new alert configuration I want you to look for, to, hey, I want you to reset state for a particular key, or even in some cases, hey, I want you to actually change the logging level for a particular key combination. And we're kind of sensitive about the cogs of our logging, so that's one way we can get fine-grained control of the logging level of a running job. Okay. So when we roll that all together, the solution that David's going to walk you through, stripped down version, but illustrates the high points. we wind up with 2 Kafka sources, one for control events, one for the data coming through. Those both flow into a filtering function. That filtering function is responsible for maintaining the alert configurations that we've sent in. And as the data events come in, it's also responsible for doing kind of a pre-flight matching of the alert configurations to each data event. And that gets forwarded then to our qualifier function, which is responsible of actually doing the JSON parsing and doing the JSON path evaluations for the alert configurations. And then if anything actually matches a particular alert configuration, it's forwarded to our counter function, which keeps a count and then outputs it to our output stream. All right, so there's one more big architectural thing. Hardwick mentioned bootstrapping. We'll let David actually get started, and then he will introduce that one to you. David?
Can you guys hear me? Can you hear me now? Cool. All right, I'm David. I write code at Better Cloud, so let's get into the code. As Sean mentioned, there were 2 sources, customer events and control events. So I just wanted to get the models out of the way really quick. The customer event has a customer ID and a payload that's just a string of JSON. The control event's got a little bit more going on: customer ID, alert ID, threshold, and JSON path are the main things that you care about. The Bootstrap customer ID is really important for a later bit, but we'll get to that in a little bit. So what does this look like? The event stream, we're reading from the events Kafka topic. The filter in the map, we like going to option from our sources, so we're just filtering out anything we don't care about. And then we're keying by customer ID for where the events get sent to. The control stream, very similar. Once again, filtering out anything we don't care about. And then the big difference here is we're splitting out. We want to be able to publish global alerts for our customers. So we publish one thing, it impacts all of our customers. So we've got this idea of a global customer ID. If it's not that, then it's a specific. After that, the control stream, if it's global, we broadcast it everywhere. We want all instances to have it. If it's specific, once again, we key by customer ID. So what does it look like to join it all together? We take the global control stream and union it with the specific control stream and then connect the event stream to that. You can probably guess that means it's going into a co-flat map. Flat map 1, all we're doing is keeping a list of the configs, the control events that have been sent in. So as a new one comes in, we'll filter out whatever needs to be replaced and throw it in. And then flat map 2, it takes in the customer events that are sent in and looks at the customer events, sees if there's any configs already saved to the system that match that customer ID. If there are, then it outputs that event along with the matching configurations, matching control events. So qualifying, this is where the JSON Path stuff comes in. And if you look at the code, you can tell that JSON Path is definitely a Java library and does like throwing exceptions. So we've wrapped it in several tries to protect exceptions from blowing up everywhere. But basically what's going on is we're parsing the payload that comes in. We get a document context for JSON path out of that. And then for each control message that we've got, we're going through and we're reading the JSON path. This is a very toned down example. The only thing we're matching on is if that path actually exists. In your system, you definitely want to be able to match, like, you'd want to be able to compare it to something. So assuming that that path does exist, we output that control event and the qualified event to the next function, which we call the counter. In here, we've just got a hash map. If the key is in the map, then we increment it. Else, we create a new key and set it to 1. So this is what it looks like all wired up, just the stream that we unions and connected like we talked about before, and then flat map them all together. So all that's great. It's pretty basic at this point. If all you care about is events going forward, that's really all you need. For us, our customers don't want to create an alert that's like, hey, show me all documents that are shared externally going forward. They want the previous stuff as well. And that was a big challenge for us. So Jason over there came up with this idea he called bootstrapping. This is basically what it looks like. So there's a few changes from before. We've got this bootstrap function at the top over the filtering function, and the counter function also has an output sync. So let's look at the changes. This is the counter function, the flat map. The main bit that's changed is in the else. Essentially what we're saying is that if we're putting it in for the first time, we've never seen any events with this before. That means that we likely have stuff historical that we've missed. So we're going to output a new control event, and that bootstrap customer ID that I talked about earlier is going to be populated. And we've got this bootstrap function. For this demo, we're just reading from an events.txt file instead of a database or anything like that, just to keep things simple. All this does is it reads the events.txt, converts them to customer events, filters out any customer events that we care about, and then for each one, it outputs a filtered event into the qualifier, so it's going to take the exact same path as before. This is what it looks like wired up. So we've added this new source listening to the bootstrap topic, and we've also got a new sync that outputs to the bootstrap topic. So it's kind of this circular thing using Kafka. As you can see, we've added the sync at the end and also hooked up the bootstrap stream as well. So there's a few notes on this that I kind of want to walk through. Real system's going to require both ingestion and some way to replay. It could be directly from an API, a database, something like that. You need to be careful how you implement it, though, because it's super easy to block the entire stream, and you don't want to do that. The async IO learned about yesterday looks like a great solution for that, but we didn't have that at the time. There should also be some kind of tracking of the event that triggered the bootstrap, because you want to be careful with the ingestion that you're not sending an event for a second time, so events don't get counted twice. And if ordering doesn't matter, you can just replay all events like we have in this example code. If ordering does matter, it gets a little bit more complicated. You're going to need to collect all of the events that come in after the bootstrap request, process all the bootstrap messages, and then process the live stream to catch it all up. So this is what our solution looks like for handling this historical data. We've got two Flink jobs. One of them is an ingest system that just puts everything in Hive, so it's queryable. The big advantage here versus like replaying the entire stream or something like that is it's really just a super small subset of the events that we're going to care about. So instead of needing to process all events ever, we're only processing events for this customer. In our case, we're only processing events for that customer and likely the provider, be it Google, Slack, something like that. So it's a much smaller subset of data to deal with. And then we've also got a replay service. For our replays, we're actually replaying onto Kafka. It bought the advantage, it's a little bit more complicated conceptually, but it bought the advantage of it's the exact same flow either way in our system. So let's show what this looks like. So I've just got the job sitting here. All the code's the exact same. If you go on GitHub, I do have example test messages just in the job, so you can play around with that. The other thing that you haven't seen that I wanted to show is we've got this events.txt file. I said I was replaying from just a flat file instead of a database, largely just to keep things simple. So this is what it looks like. There's 20 events, and I believe 9 of them match. So we'll go ahead and run that. Here I've got just a few quick scripts to send the Kafka messages, so I'll just show what they look like. All we're doing is using the console producer and passing in whatever we want. So I'll send a few example messages just to kind of show. All right, so I sent that. Nothing's happening because we don't have any controls in yet. Doesn't matter what you send. Until a control comes in, nothing matters. So we'll send the control message. Actually, I'll put that real quick. So here's what the control message looks like. Dead beef is the global customer ID that we ended up using because it's a valid UUID and it makes us laugh. There's also the JSON path, so we're looking for store, the first book in the array, author, threshold of 2. So let's go ahead and send that in. All right, nothing's happening yet. We'll go ahead and send in an unmatched message. So this won't trigger anything because it's not going to match the path. But when we send a matched event, down here you see, everyone see that okay? First message hit, said, all right, great, I need to bootstrap this, put a message on Kafka, and these 9 messages then replayed. We send another one, it's just going to increment 1 right here. So that's pretty much the system at a glance. So a few areas for improvement. The most expensive operation in our system is the JSON Path operations. We ran into issues a couple weeks ago where we had one new customer who, for various reasons, was several orders of magnitude larger than anything that we'd had before, and it just completely screwed up the keyed stream, started blocking other customers. So we're moving towards broadcasting all alerts instead of just global, and the keyed stream as late as possible. Realistically, you don't need the keyed stream until you start counting. Obviously, state needs to be saved at a minimum. Controls and counts should be. Current models only support incrementing. You're likely going to want to decrement. It's pretty trivial. JSON path, super powerful, so you can do comparisons. It's got a whole concept of types. Like if for whatever reason you want to compare greater than, less than on an integer, no problem there. And only a single property path is supported with this. You'd likely want to support multiple. So that's about it. We're hiring, go figure. Been there 2 years and basically been hiring the entire time I've been there constantly. If you're at all interested, career site's there, or David Hardwick is in the back. Talk to him. Any questions? Yes. It's not that big of a deal. So, how do we ensure that when we bootstrap that we're consuming the control messages before we consume the data? So we don't try to immediately bootstrap when we get a control event. We wait until a matching event comes in. It kind of automatically spreads out the load some. Mm-hmm. So when we're restarting, you lose state sometimes. So when we're restarting, all the configurations are also stored in a MySQL database. So we read them out of that, and if state's already there, that's great. But does that kind of answer your question? Any other questions? What's up? We have not. This was a very stripped down. Sorry. Have we looked at using the? The built-in iteration instead of Kafka to loop back? We haven't. This was a very stripped down of what we run in production, and with us having the separate services, we use Kafka anyways for the communication. Anyone else? What's up? How would you change what we've done if we trusted Flink to store all the state? So we're still on Flink 113, and the main reason that we can't completely trust it is because of the scaling. So once we upgrade and switch to the managed state everywhere, it's going to be a whole lot easier to trust it. But we've been using this product for less than a year, so there's just been some learning curves associated with that. As far as what we would change, I'm not sure. We probably wouldn't be writing to MySQL as much and be as concerned about being able to restore from there for when we do have the scaling differences.
To follow up to that, the query API with Flink is a lot better than it is as well. We wind up doing some fairly robust querying on the backside using Elasticsearch. So you need to kind of get closer to parity through that before we can search it for Flink as our primary data source. So when that three changes, Flink still needs. They certainly get really close. I'll say we will definitely start playing with that.
Anyone else? Cool. Thank you very much.